Okay, so now we are going to do the light independent part of photosynthesis, where we take CO2 and we're going to use our energy carriers from photosystems 1 and 2 to make glucose. We've already dealt with the water. We split that, formed oxygen. Now we're just dealing with CO2 and glucose. So if you go over here, you can see I've got an arrow coming from the other side of the paper, and we have NADPH and ATP that are from photosystems 1 and 2. We're going to use those to energize molecules and help convert them into sugar. And we're going to start here on the left-hand side of the paper. We have carbon dioxide combining with a 5-carbon molecule. It's not that that molecule doesn't have anything else in it. Of course, those carbons are going to be bonded to hydrogens and possibly oxygens. We're just not going to show those for simplicity's sake. So we've got that 1 carbon dioxide combining with the 5-carbon molecule to form a 6-carbon molecule. It's unstable and splits into 2 molecules, each with 3 carbons. And then they get energized and rearranged a little bit by ATP, and of course that came from our photosystems. ATP, and once we use up the energy, it becomes ADP, and we're actually going to put some phosphates on here. Then we have our NADPH. We're going to use up the energy that's in that electron on the end of it. So we're going to wind up with NADP. And we make it a little bit exciting. I'm going to draw some E's here. Get these molecules excited. They just rearranged a little bit, and one of them is actually going to leave. Just a second. One of them is actually going to leave the cycle. The other one's going to stay. And then we will use that molecule to complete a second cycle. So we've already gone all the way around. But here's the trick. We went from 3 carbon molecule to 5. 3 to 5. How'd that happen? Well, it would make more sense if we had 3 of these at each stage. Then the math makes sense. We're only going to have 1 of them leave. Now, we had 3 and 3 gives you 6 molecules. 1 of them left. Now we are going to have 5. Right? Because 6 minus 1 gives you 5. So we have 5 3-carbon molecules. So 5 times 3 gives you 15. There were 15 carbon atoms present. If we look over here, we have 3 5-carbon molecules. And 3 times 5 gives you 15. So we didn't lose anything. It's all still there. It just got rearranged, and the molecule that helped to rearrange it was ATP. And convert that to ADP, harvest the energy. Summary. We used carbon dioxide and energy carriers, E, carriers, to make glucose. And that's it. So if you want to stay for the actual instructions that I'm going to write out, then you can continue watching, and if not, then feel free to watch something else. Step 1, CO2 combines with a 5-carbon molecule. 5C is how I'm going to abbreviate that. 5-carbon molecule. And I want you to put in parentheses, this was done by Rubisco, which is a common enzyme in plants. Step 2, our unstable molecule splits. Step 3, our energized molecule rearranges. Step 4, 1 molecule leaves. And step 5, our molecule rearranges to prepare for the next cycle. Now you'd actually have to have more than one of these come out of the cycle if you wanted to make glucose, because remember that glucose is C6H12O6, and this only has 3 carbons in it. And that's it.